Lesson 4.3 covers linear programming. There's a couple of different methods to solve linear programming problems. The method that Lesson 4.3 covers is solving them graphically. In the previous lessons, we've looked at all the pieces we need to solve a linear programming problem. And now we're going to look at the applications. So when you're looking at a linear programming problem, the applications, the word problems, let's look at the steps to solving that. The first step is to state the purpose of the problem. And this is usually to maximize or minimize something. We usually maximize the profit or minimize the cost. Those are two examples. The second step is to state what the variables represent and be very specific. This is going to help you when you're giving your final answers. Next, we state the objective function. Then we list all of our constraints. We're going to graph the constraints. Using the graph, we're going to list the corner points. We're going to evaluate the objective function at each corner point. We're going to plug the corner points into the objective function. And then finally, in words, we're going to state what the solution is. So let's look at a few applications. A farmer has 70 acres of land available on which to grow some tobacco and cotton. It will cost the farmer $60 to cultivate each acre of tobacco and $30 to cultivate each acre of cotton. It will take the farmer 3 days to cultivate each acre of tobacco and 4 days to cultivate each acre of cotton. The farmer wants to spend no more than $1,800 and 120 days on cultivation. The farmer expects a profit of $300 per acre of tobacco and $150 per acre of cotton. Find the number of acres of each crop that should be planted in order to maximize the profit. So the first thing we do is we always list the purpose of the problem. This is usually stated in the last sentence. It's what you're asked for. I want to maximize the profit in this example. Then we decide what the variables are. Again, look at the last sentence. It's find the number of acres of each crop. Those are my unknowns, so that's what my variables are going to be. My two crops were tobacco and cotton. Just for grading consistency, list these in the order they're given. Since tobacco was given first, we're going to let X be the number of acres of land used for tobacco. Cotton was listed second, so let it be your second variable. Y is the acres of land used for cotton. Then we find our objective function, just to get it out of the way. Look back at the purpose of the problem. I want to maximize the profit, so my objective function is going to deal with profit. Well, the farmer expects a profit of $300 per acre of tobacco and $150 per acre of cotton. So P is 300X plus 150Y. Then you look back through the problem and you find any other constraints that you're given. And these are just restrictions. What's keeping that farmer from planting as many acres as he wants? Well, the first thing I'm told is the available land. He has 70 acres to plant for land. So if I take my acres of tobacco, which is X, and add that to the number of acres of cotton, which is Y, it cannot be over 70. It's got to be less than or equal to 70 because he only has 70 acres of land. Then the next thing the problem talked about was the cultivation cost. Well, it costs $60 per acre of tobacco, so this gives me 60X. And it costs $30 per acre of cotton, so add to that 30Y. He doesn't want his cost to exceed $1,800, so he wants this cost to be less than or equal to $1,800. Then the next constraint they tell me about is time. or the days needed for cultivating. It takes 3 days for each acre of tobacco, so that's 3x. It takes 4 days for each acre of cotton, so that's plus 4y. He only has 120 days to use, so this needs to be less than or equal to 120 days. And then don't forget about our implied constraints. The number of acres used for each crop can't be negative, so x and y both need to be greater than or equal to 0. So this gives me the following system. I have x plus y is less than or equal to 70, 60x plus 30y is less than or equal to 1800, 3x plus 4y is less than or equal to 120, and x and y are both greater than or equal to 0. So I want to list my boundary lines, find my corner points, and graph this system of inequalities. So if I begin with the x plus y is less than or equal to 70, I know I've got a solid boundary line. All of my boundary lines are going to be solid. And this boundary line is x plus y equals 70. So for my x-intercept, let y be 0. If y is 0, I get x equals 70, so I have the x-intercept 70, 0. For the y-intercept, let x be 0. If x is 0, then y equals 70, so I have the y-intercept is the point 0, 70. Then my next boundary line is 60x plus 30y is less than or equal to 1800. This is also a solid boundary line. So I want to find my x-intercept. For the x-intercept, let y be 0. If y is 0, I have 60x equals 1800. If I divide each side by 60, I get that x equals 30. So this gives me the x-intercept is the point 30, 0. Then for the y-intercept, let x be 0. If x is 0, you have 30y equals 1800. Then if you divide each side by 30, you get y equals 60. So you have the y-intercept is the point 0, 60. Then my third constraint was 3x plus 4y is less than or equal to 120. And again, as we mentioned, all our boundary lines were solid. This is a solid boundary line. So if I find my x-intercept, I let y be 0. So 3x equals 120. If I divide each side by 3, I get x equals 40. So this gives me the intercept 40, 0. Then for the y-intercept, let x be 0. If x is 0, 4y equals 120. If I divide each side by 4, I get y equals 30. So this gives me the intercept 0, 30. So I always begin with my constraints, the x and y are greater than or equal to 0. This tells me I'm limited to quadrant 1 because there will be no negative x values and no negative y values. So shade or mark out all other quadrants. Then for the next boundary line, I have the intercept 70, 0 and 0, 70. On my graph, I'm going to use a scale of 10. So for 70, 0, I go over 7 places. And for 0, 70 on the y-axis, I go up 7 places. And I'm going to draw a solid boundary line through these and label that line 1. Since that does not go through 0, 0, I can test 0, 0. Go to your original inequality, x plus y is less than or equal to 70. If you plug in a 0, 0, you get 0 is less than or equal to 70. And this is true. So since 0, 0 was true, everything below the line is true. So I'm going to shade what's false, which is above the line. Then my second boundary line, 60x plus 30y equals 1800, I have the intercepts 30, 0 and 0, 60. So this is going to look like the points 3, 0 and 0, 6 on a scale of 10. So draw a solid boundary line through these intercepts and label it line 2. This boundary line also does not go through 0, 0, so I can test 0, 0. If I plug in 0, 0 into my original inequality, 60x plus 30y is less than or equal to 1800, I get 0 is less than or equal to 1800, and that's true also. So 0, 0 was true, so the other side is false. Always shade or mark out the side that's false. My third boundary line was 3x plus 4y equals 120. And this was a solid boundary line with the intercepts 40, 0 and 0, 30. So those are going to look like the ordered pairs 4, 0 and 0, 3. So draw a solid boundary line through those and label that as line 3. And just like my other two boundary lines, this does not go through 0, 0, so I can test 0, 0. Go to the original inequality, the 3x plus 4y is less than or equal to 120. If you plug in 0, 0, you get 0 is less than or equal to 120. This is true, so I do not shade 0, 0, I shade the other side. So my feasible solution area is the bounded region in the corner of my first quadrant. Since it's enclosed on all sides by boundary lines, this is a bounded area. I can easily find a couple of my corner points because they're intercepts. The first one is the intercept 30, 0. The second one is the intercept 0, 30. Since this feasible solution area is in the corner of quadrant 1, the equations x greater than, the inequalities x greater than or equal to 0 and y greater than or equal to 0 intersected at the point 0, 0. So that's also a corner point. And then my fourth corner point is going to occur where lines 2 and 3 intersect. This is why I label my lines so I can easily tell which lines intersected to form those corner points. So let's look at the intersection of lines 2 and 3. Line 2 was 60x plus 30y equals 1800, and line 3 was 3x plus 4y equals 120. Well, think of these as a system of equations, and I can eliminate either my x's or my y's. If I multiply the second equation by a negative 20, I'll get a negative 60 as the coefficient for my x, and I can eliminate my x's. So bring down your first equation, 60x plus 30y equals 1800. If you multiply everything in the second equation by negative 20, you get negative 60x minus 80y equals negative 2400. If I add these, the 60x minus 60x cancel, they eliminate. 30y minus 80y is negative 50y. And 1800 minus 2400 is negative 600. If I divide each side by negative 50, I get y equals 12. Now I want to find my x, so plug that y into either equation. I'm going to use the 3x plus 4y equals 120. So if I replace the y with a 12, I have 3x plus 4 times 12 equals 120. Well, 4 times 12 is 48, so I have 3x plus 48 equals 120. If you subtract 48 from each side, you get 3x equals 72. And then if you divide by 72, you get x equals 24. So the fourth corner point is at the point 24, 12. Be sure to always list the x first. Now I take all 4 corner points and plug them into my objective function, which is p equals 300x plus 150y. So if I plug in 30, 0, I get 300 times 30 plus 150 times 0. And 300 times 30 is 9,000. If I plug in the 0, 30, I get 300 times 0, which is 0, plus 150 times 30, which is 4,500. If we plug in the 0, 0, we just get 0. And then if I plug in the 24 and 12, I get a 9,000. We'll look back at the purpose of the problem. I want to maximize the profit. Well, I have 2 highest values. I have 9,000 twice. So that means I have the option. I can either plant 30 acres of tobacco and no acres of cotton from the ordered pair 30, 0, or I can plant 24 acres of tobacco and 12 acres of cotton, and this is from the point 24, 12. And either way I choose, I get that my maximum profit is $9,000. Let's look at the next example. Boats R Us makes 2 types of inflatable rafts, 2-person rafts and 4-person rafts. A 2-person raft requires 4 hours of fabrication and 1 hour of finishing. A 4-person raft requires 6 hours of fabrication and 1 hour of finishing. Each week, 108 hours of fabrication time and 24 hours of finishing time are available. If the company earns a $30 profit on 2-person rafts and a $40 profit on 4-person rafts, how many of each type of raft should be made to maximize the weekly profit? So let's go to our steps for solving the linear programming problem. The first step is we want to look at our purpose. The last sentence told us we want to maximize the profit. Then next, you find your unknowns. Well, we're asked how many of each type of raft should be made. So our unknowns are the types of rafts. List these in the order they're given. I'm first told about the 2-person raft, so let's let X be the number of 2-person rafts. Then the second one was the 4-person rafts, so we'll let Y be the number of 4-person rafts that are produced. Then you go to your objective function. Look back at the purpose. The purpose was to maximize the profit, so the objective function is going to deal with profit. I earn a $30 profit on each 2-person raft produced and a $40 profit on each 4-person. So my profit is 30x plus 40y. Now let's look back through the problem and let's find our constraints or our restrictions. The first thing we're told about is the time needed for fabrication. Well, each 2-person raft requires 4 hours, and each 4-person raft requires 6 hours. So I have 4x plus 6y. I only have 108 hours available, so this must be less than or equal to 108. Then I look at the time needed for finishing. Well, each 2-person raft requires 1 hour, and each 4-person raft requires 1 hour. So I have x plus y. I only have 24 hours available, so this must be less than or equal to 24. I'm not given any other restrictions in the problem, so always look for the implied restriction. The number of rafts produced cannot be negative. So X and Y both must be greater than or equal to 0. So this gives me my system, which I have 4X plus 6Y is less than or equal to 108. X plus Y is less than or equal to 24. And X and Y are both greater than or equal to 0. Now we want to graph these. So let's begin with our first constraint. I notice that it's a solid boundary line. My boundary line is 4x plus 6y equals 108. For my x-intercept, let y be 0, and I get 4x equals 108. If I divide each side by 4, I get x is 27. So this gives me the ordered pair 27, 0. Then next, for the y-intercept, let x be 0. If x is 0, 6y equals 108. If I divide each side by 6, I get y is 18. So this gives me the ordered pair 0, 18. My second constraint is x plus y is less than or equal to 24. This is also a solid boundary line, and the boundary line is x plus y equals 24. So for my x-intercept, let y be 0, and I get x equals 24. So this gives me the ordered pair 24, 0. For the y-intercept, let x be 0, and I get y equals 24. So this gives me the ordered pair 0, 24. So now I'm ready to graph. I always begin with my implied restrictions. The x and y are greater than or equal to 0. This lets me know I cannot use any negative values. I can't make a negative number of rafts. So I shade or mark out everything except quadrant 1. Now I begin with the 4x plus 6y equals 108. My intercepts were 27, 0 and 0, 18. For my second line, my intercepts were 24, 0 and 0, 24. Since these were all multiples of 3, I'm going to let my scale be 3. So to plot the point 27, 0, if my scale is 3, if every line represents 3, I need to go over 9 lines to get to 27. So it's going to look like the ordered pair 9, 0. Then for my y-intercept, if it's 0, 18, 18 divided by 3 is 6, so I've got to go up 6 lines to get to my y-intercept. So it's going to look like the ordered pair 0, 6. I draw a solid boundary line through these, and I'm going to label it as line 1. Since this line does not go through 0, 0, I can use 0, 0 as my test point. If I go back to my original inequality, 4x plus 6y is less than or equal to 108. Plugging in 0, 0 gives me 0 is less than or equal to 108, and that's true. Since 0, 0 was true, every point below the line is part of the solution for this line. So I shade or mark out the area above the line. Next, we want to graph the boundary line for x plus y equals 24. So I have both intercepts. I have 24, 0 and 0, 24. If I divide those 24s by 3, I get 8. So these are going to look like the points 8, 0 and 0, 8. So I draw a solid boundary line through these points. And I label this line as with a 2. That was my second boundary line. Since this line does not go through 0, 0, I can test 0, 0. My original inequality was x plus y is less than or equal to 24. So plugging in 0, 0 gives me 0 is less than or equal to 24, and that's true. Since 0, 0 is true, I do not shade the side with 0, 0. I shade or I mark out the other side. So shade above the line. So this gives me the feasible solution area in the corner of quadrant 1 again. It's four-sided and it's enclosed on every side by a boundary line, so it's a bounded solution area. So let's list our corner points. My first corner point was an x-intercept, and that was the point 24, 0. My second corner point was a y-intercept, and that was the point 0, 18. I've got a third corner point at the origin, 0, 0. And then my fourth corner point occurs where lines 1 and 2 intersect. So the fourth corner point is at the intersection of lines 1 and 2. And always find that using substitution. So let's look at the intersection of lines 1 and 2. If I put lines 1 and 2 together, this gives me the system 4x plus 6y equals 108 and x plus y equals 24. You can eliminate either the x or the y, it doesn't matter. If I multiply the second equation by -4, my x's will eliminate. So recopy your first equation, 4x plus 6y equals 108. -4 times the second equation gives me -4x minus 4y equals -96. So if I add these, the 4x and the -4x eliminate. 6y minus 4y gives me 2y, and 108 minus 96 gives me 12. If I divide each side by 2, I end up with y equals 6. So now that I have my y, I need to find my x. So go to any of the equations. I'm going to use the x plus y equals 24. If I replace y with 6, I get x plus 6 equals 24. Now subtract 6 from each side and I get x equals 18. So this gives me my fourth corner point is the ordered pair 18, 6. So my corner points are 24, 0, 0, 18, 0, 0, and 18, 6. I'm going to plug each of these into the objective function, which is p equals 30x plus 40y. If I plug in the 24, 0, I get 30 times 24 plus 40 times 0, and this is 720. If I plug in the 0, 18, I get 30 times 0 plus 40 times 18, and this is also 720. If I plug in the 0, 0, I'd get a 0. 30 times 0 plus 40 times 0 is 0. And then finally, if I plug in the 18, 6, I get 30 times 18 plus 40 times 6 is 780. Look back at the purpose of the problem. I wanted to maximize the profit, so I want the highest value. I want the 780. So that means my maximum profit is 780 when I make 18 two-person rafts and 6 four-person rafts. Now for our final example, a cereal company plans to combine bran and oats to manufacture at least 30 tons of a new cereal. The amount of oats must be at least twice the amount of bran. If bran costs $275 per ton and oats cost $350 per ton, how much of each ingredient should be used to minimize the cost. First, let's state the purpose of the problem. This time I was asked to minimize the cost. Next, we look at what our unknowns are going to be. We're asked how much of each ingredient. I have two ingredients, bran and oats. Let X be the first one, so X is the amount of bran used, and Y will be the amount of oats used. Then let's look for our objective function. Since we wanted to minimize the cost, the objective function is going to deal with the cost of each of these. Bran cost $275 per ton, and oats cost $350 per ton. So I have 275x plus 350y, and this time I let this equal a c for cost. It doesn't really matter what variable you use. Generally, if it's profit, I'll use a P. If it's cost, I'll use a C. Now let's look at our restrictions. The first restriction we're told is we want to produce at least 30 tons of a new cereal. So you take the amount of brans and add that to the amount of oats, X plus Y. It needs to be at least 30 tons, so it could be more. So I want this to be greater than or equal to 30. Then my second restriction, I'm told the amount of oats must be at least twice the amount of bran. Well, the amount of oats was Y. That needs to be at least twice the amount of bran, so that needs to be greater than or equal to 2 times the amount of bran, which is 2x. I'm not given any other restrictions, so look for your implied restrictions. I can't have a negative amount of either ingredient, so I'm going to have X and Y both greater than or equal to 0. So this gives me my system. I have X plus Y is greater than or equal to 30, Y is greater than or equal to 2X, and X and Y are both greater than or equal to 0. So let's begin by finding my boundary lines and my intercepts. For X plus Y is greater than or equal to 30, I know I'm going to have a solid boundary line. The equation for that line is X plus Y equals 30. For my x-intercept, let Y be 0. If Y is 0, I get X equals 30, so this is the ordered pair 30, 0. For the y-intercept, let X equal 0. If X is 0, I get Y equals 30, so this is the ordered pair 0, 30. Then next I have Y is greater than or equal to 2X. This is also a solid boundary line, and the equation is Y equals 2X. Well, for the x-intercept, let Y be 0. If Y is 0, I have 0 equals 2X. If I divide each side by 2, I get X is also 0. So I have the ordered pair 0, 0. Well, since this line goes through the origin, I know my y-intercept would also be 0, 0. And if you wanted to double check, if you plug a 0 in for X, you get Y is 2 times 0, so Y is also 0. Now I just have one ordered pair. I need 2 to graph it, so I need a second point. For your second point, let either X or Y be any value. Now to make it easier, I'm going to plug a number in for X since X has the 2 with it. And I look at my intercepts for the other equation. They were multiples of 10, so I'm going to use a multiple of 10. So I'm going to let X be a 20 because it's close to the 30 from the other equation. If X is 20, Y is 2 times X, which is 40, so I get that Y is 40. So my second ordered pair is the point 20, 40. So just like with the other examples, I'm going to begin with my implied restrictions, the x and y greater than or equal to 0. This tells me I have no negative x or y values, so I'm marking out anything that's not in quadrant 1. Then my next equation is x plus y equals 30. So my intercepts were 30, 0, and 0, 30. I'm going to use a scale of 5. So if my scale is 5, the 30s divided by 5 give me 6. So it's going to look like the ordered pair 6, 0, and 0, 6. You can use any scale you want. I try to make my scale as small as possible. Like I didn't want to use a scale of 10 because then the graph is so small sometimes it's hard to see the feasible solution area. So 5 was a good number to use. You also could have used a 3. Now draw a solid boundary line through these and label that as line 1. Since that line does not go through 0, 0, I can test 0, 0. Go to your original inequality, the x plus y is greater than or equal to 30. When I plug in 0, 0, I get 0 is greater than or equal to 30, and this is false. Well, since 0, 0 is false, every point below that line is going to be false. So shade the false area or mark out the false area. Then my second boundary line is y equals 2x. This goes through the point 0, 0, which is my origin, and 20, 40. Well, 5 will go into 20 4 times, and 5 will go into 40 8 times. So this is going to look like the ordered pair 4, 8. If I draw a solid boundary line through these, I need to label it as line 2. Well, this time that line does go through 0, 0, so I need to test some other point. Just pick any point that's not on the line. So I'm going to use 10, 5. If my scale is 5, if I start at 0, 0, that's 5, this is 10, and I go up, so 10, 5 would be this ordered pair right here. It's going to look like the ordered pair 2, 1. Well, if I go to my original inequality, I get y is greater than or equal to 2x. If I plug in the 5 for the y and the 10 for the x, I get 5 is greater than or equal to 2 times 10. So 5 is greater than or equal to 20. That's false. So this point 10, 5 is false. So that means every point below or to the right of line 2 is false. So I mark out my false side. So this tells me my feasible solution area is in the upper left-hand corner. It does not have a top boundary line. I don't have a boundary line around the top, so this is an unbounded solution area. I want to begin with my corner points. Well, I've got one corner point that's an intercept, so that was the point 0, 30. My second corner point is where lines 1 and 2 intersect. Those are my only two corner points. Because this is unbounded, I don't have any corner points at the top. I'm going to find the second corner point by looking at the intersection of lines 1 and 2. Think of this as a system. X plus y is equal to 30 and y equals 2x. You can solve this system with the substitution method. I just didn't cover that in my lessons. So I'm going to stick with the elimination method. In order to use the elimination method, I need these equations to be in the same form. So I'm going to take my 2x and move it to the other side of the equation, and it's going to become negative. Then I've got the positive y that's already over there. And when I move the 2x over, there's nothing left on this right-hand side, so it equals 0. So now I have x plus y equals 30 and negative 2x plus y equals 0. I can eliminate my y's if I multiply either equation by negative 1. I'm going to go ahead and take that second equation and multiply both sides by negative 1. So if I rewrite my first equation, I have x plus y equals 30. Then my second equation becomes 2x minus y equals 0. If I add these, the x plus the 2x is 3x. The y minus y makes my y's eliminate. And 30 plus 0 is 30. Now I solve for x by dividing each side by 3 and I get x equals 10. Since I have x, I need to find my y. So go to any of your equations. I'm going to use x plus y equals 30. If x is 10, I have 10 plus y equals 30. Then if I subtract 10 from each side, I get y equals 20. So my corner point is the ordered pair 10, 20. This system only had two corner points, 0, 30 and 10, 20. Plug each of these into your objective function, which was c equals 275x plus 350y. So if I plug in the 0, 30, I get 275 times 0 plus 350 times 30 gives me 10,500. Then if I plug in the 10, 20, I have 275 times 10 plus 350 times 20 gives me 9,750. Now look back at the purpose of the problem. This is why we listed it. The purpose was to minimize the cost. So this time I want the smallest value. I want the minimum. So my minimum cost is $9,750 when they use 10 tons of bran and 20 tons of oats.